Motion does not happen on its own. Some force has to be applied for motion to occur or to change the state of motion. The relationship between motion and force was explored by Isaac Newton in his famous laws of motion. He formulated three laws that clearly explain how force affects motion and why objects behave the way they do. Let's start with the first law of motion. The first law states that an object will remain at rest or continue moving in a straight line with constant velocity unless acted upon by an external force. This law is also called the law of inertia because inertia is the property of an object to resist any change in its state of motion. In simple words, objects like to stay the way they are, either at rest or in motion, unless something forces them to change. For example, when a bus suddenly stops, passengers or loose objects move forward because their bodies try to remain in motion. They only stop when another force acts on them, such as the seat or a handle. Similarly, if a book is lying on a table, it will not move unless someone pushes it. To move a shopping cart, we have to apply force in the direction we want it to go. Next up, second law of motion. The second law states that the rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of that force. In simpler terms, this law explains how force, mass, and acceleration are related. The greater the force applied, the greater the acceleration produced. Also, heavier objects require more force than lighter objects to achieve the same acceleration. F equals to ma. This means force is equal to mass times acceleration. So if mass increases, more force is needed, and if force increases, acceleration also increases. For example, pushing a car requires much more force than pushing a bicycle to achieve the same acceleration. Similarly, kicking a football makes it move faster than kicking a heavier object, like a stone with the same force. Third law of motion. The third law states that for every action, there is an equal in magnitude and opposite in direction reaction force, and this forces acts on different bodies. This means forces always occur in pairs. One force cannot exist without the other, and since they act on different objects, they do not cancel each other out. For example, when you walk, you push the ground backward with your feet, and the ground pushes you forward with equal force in the opposite direction, helping you move. When you push a wall, the wall pushes back on you with the same amount of force, which is why your hand feels resistance. A very common and important example is a rocket. A rocket pushes gases downward at high speed, and in return the gases push the rocket upward with equal force, allowing it to move into space. Overall, these three laws form the foundation of classical mechanics and help us understand everything from everyday movements to complex systems like vehicles, machines, and even space travel. Thanks for watching till the end. If you liked the video, don't forget to like, share, and subscribe for more science content. Comment below what topic you would like to explore next. Stay safe. Bye bye.